Okay, so let's assume that we have binomial theorem. Let's assume that we know that a plus b to the n is equal to the sum from k equals 0 to n choose k, a to the k times b to the n minus k. And this is something we have for sure, 100%. Remember this and hold on to it because we're going to use it. What we're going to do is we're going to look at the Fibonacci recurrence. So we're going to look at f of n equals f of n minus 1 plus f of n minus 2. You probably have seen this before. N needs to be greater than or equal to 2 for this to work. And your initial conditions are f of 0 equals 0 and f of 1 equals 1. Some people would rather have f of 0 equals 1. It doesn't make a big difference. It just matters whether you think of this as the first Fibonacci number or the 0th Fibonacci number. Either way. But what we're going to do now is we're going to find the generating function for this sequence, for the Fibonacci sequence. And so the trick is the same as before. I'm going to set up a function, a of x, which is going to be the sum from n equals 0 to infinity f of n x to the n. And then I'm going to use that along with this recurrence, so I'm going to have f of n x to the n equals f of n minus 1 x to the n plus f of n minus 2 x to the n. And this is going to be valid for n equals 2 to infinity because that's where my recurrence conditions are valid. When we do this, this is almost a of x, but it's missing the first two terms. So here we get a of x minus 1x minus 0, because I have to subtract off the first two terms here, is equal to, here I'm going to need to factor out an x and do the index shift. So that is,
Hey, Dad.
Hey Addie, how's it going, sweetie?
I just want to do what you are doing.
Okay.
I really want to do that.
Oh, would you like to help me write on the board?
Help you write on this board.
Okay. Let me factor out an x squared here.
Are you helping me make that?
Yeah.
But I'll need a marker too.
Okay. Can you look for a marker while I work through this? Okay. Cool.
Can you pick me up so I can write?
So y'all try to solve this recurrence. I'm going to write it one more time. Or try to solve this for a of x. So what we have right now is a of x minus x is equal to x times the sum. And I can do this trick we did before where I shift this down. So this is n equals 1 to infinity.
So I can write, please.
Okay, honey, hold on 1 second.
A flatty. A's flatty. A's flatty. A's flatty. A's flatty.
Yeah.
3A's flatty.
You're right. So this this is actually a of x. So you can clean this up and solve for a of x, and then we'll come back and discuss what the answer is.